Hello students, I am Nidishtes Bagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we were discussing regarding periodic classification of elements and we discussed the various periodic tables and their inventions. And finally, we got to know the modern periodic table regarding the properties of modern periodic table. Today, we are going to discuss in detail regarding the modern periodic table. I think the screen is visible for you all. Fine. Okay. So as we were discussing regarding position of hydrogen in the periodic table, we know that it is the first element, right? So it is the lightest, smallest, and the first element in the periodic table. Its electronic configuration is 1s1, where it has one electron in its valence shell. It occupies unique position because it behaves like alkali metal as well as halogen. Halogen means chlorine, iodine, bromine, like that. It also behaves like alkali metals, okay, which are found in the earth. Alkali metals means they are found in the earth. Okay, so it has a it behaves means it shows a property of both. That is why it is special. In the periodic table, it is placed at the top of the alkali metals. It can lose its only electron to form a hydrogen ion. So why it is called as alkali metal means it has a capacity to lose an electron. It can also gain one electron to form hydride ion. It has a capacity to lose one electron. It has a capacity to gain an electron. That is why it behaves like both as alkali metals as well as halogens, guys. So alkali metals are solids while hydrogen is a gas. Since the position of hydrogen in modern periodic table is still under debate because of its gaseous form of the state. Gaseous state, it is in a debate. Now, position of rare gases. So what are rare gases? What we can call it as inert gases, guys, which are not reactive, which are very stable and they will not react with other elements very soon. So the elements or rare gases here are helium, neon, xenon, krypton, radon. So these are the group of argon. So these are the group of rare gases or inert gases, or also we can say noble gases. So those are monoatomic gases, single atom, and they will not react with any other substances easily. Why? Because they will be having completely filled shells or an octet electronic configuration. That is why they are called inert, as they are not reactive. But they are found in very small quantities in the atmosphere. That is why they are named as rare gases. Then, then we will be having the metals, which are typically hard, shiny, malleable, ductile, can be drawn into wire, can be drawn into sheet, and are the good conductors of heat and electricity. Except we have mercury, where most of the metals are solid, mercury is a liquid. Then we will be having the larger area of the periodic table will be occupied by the metals. And again, they are divided into alkali metals, alkaline earth metals, transition metals, p block metals. Alkali metals are from lithium to francium. Alkaline earth metals, so that is beryllium to radium. Transition, group 3b to 2a. P block, aluminium, and tin, lead. So these all will come under P block elements, sorry, metals. Then non-metals are also included in the periodic table. A non-metal is an element that does not have a character like hardness, shiny and all. So in other words, it is an element that do not have a property of a metal. And all the non-metals are arranged in the P block only. In the P block, you can see the non-metals. Metalloids, which have the property of both metals and non-metals. Then alloys. What are alloys actually? So here during 3500 BC, people used an alloy which is called bronze. Okay. The idea of making an alloy was quite old. It is not a recent one. It is quite old because we already saw it in 3500 BC. The people used it. The majority of the metallic substances what we use today are the alloys, because when metal react with the moisture and the oxygen, they will corrode. So to prevent that, they will make it as an alloy. So what is alloy actually? It is a mixture of two or more metals or metal and a non-metal. Rarely non-metals are also mixed with the metals to produce the alloys. So what is that? It is generally found that alloying produces metallic substance that has more useful property than compared to the original metal. For example, alloy of brass is made up of copper and zinc. Brass, bronze, nichrome, which we learned in electricity. So these all are the alloys, guys. Advantages. See how many advantages we have in the alloys. They do not get corroded and they are harder and stronger than the metals. They have less conductance than poor metals. Copper is a good conductor. Electricity, whereas brass and balls are not a good conductors of electricity. Some alloys have lower melting point. For example, solder is an alloy of a lead which has lower melting point, which we will use to solder or melt that wire. When metal is alloyed with mercury, it is called amalgam. What is amalgam? When any metal is alloyed or is mixed with the mercury, it is called amalgam. So this is regarding the advantages of alloys. Then the next sub-concept is properties of elements in periods and groups. So what are the properties of elements? The first one is valence electron. What do you mean by valence electron? The number of electron which is present in the valence shell, in the last shell of an atom, is called as valence electron, right? In a period, the number of valence electron increases from 1 to 8 from left to right. As you see, this is a one period, right? This is a one period. We have 7 periods, 18 groups, right? So here, example, second period they took. So we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. As you can see, atomic number that is AN means atomic number. 3, 4, just a minute. Fine. So 3, 4, 5 atomic number is increasing by 1 unit. Electronic configuration, when you see the valence electrons are increasing by 1 unit. Okay. So from left to right, the valence electron increases along the periods. Okay. And when you see the shells, the number of shells remain constant along the period from left to right. So this is regarding the valence electron. Okay. In a group, the number of valence electron is same for all the elements, but the number of shells increases from top to bottom. Group means column, right? So here, hydrogen, lithium, sodium, potassium. Just a minute. Yeah. So here, atomic number is given in this 1, 3, 11, 19. As you see the electronic configuration. So the electronic configuration, what is happening? The valence electron, when you see in all the atoms, it is one only, right? In all the atoms, it is one. Just a minute, I will show you. Right. See here, when you see the valence electron in all the atoms along down the group. So what is happening there, guys? All the atoms have same valence electron, 1, 1, 1, 1. In last shell, they have 1, 1 electron only. Shells, as you see the shell, here it is 1 shell, here it is 2, 3, 4. Valence shell is increasing down the group. Valence electron remains the same down the group. Valence electron increases along the period. Valence shell remains the same along the period. So this we should remember. Next, valency. What is valency? In a period, the valency of the element increases from 1 to 4 and then decreases from 4 to 0 from left to right. Let us consider again the second period. Atomic number, electronic configuration, valence electrons, right? So 2, 3, as the valence electrons will be, they will be increasing by 1 along the period. So valency, as the valence electron increases, valency also increases, right? So here from 1 to 4, it is increasing. But from 4 to, what you can say, and then decreases from 4 to 0, see here. In a group, the valency is the same for all the elements. So valency will be same for the all the elements as the valence electron are same. Atomic size. What do you mean by atomic size? The size of an atom. So the what we can say, if this is an atom, this is a nucleus, this is a radius, this size is called as atomic size. The atomic size of an element decreases from left to right because nuclear charge or number of protons increases. So the electrons are pulled closer to the nucleus. As you saw regarding the valence electron, so valence electron increases, but the shells remain constant along the group. When the shells remain constant, valence electron increases. It shows that protons also increases. Increase in number of protons, increase in, see here, 3, 4, 5, 6. It is same to the electron. Na? Why? Because number of electron will be equal to number of protons. So as the number of proton increases, so what happens there? The force between the electron and the proton in the inside the nucleus. Okay, so that force will be more. That force, this proton pulls these electron towards it. That is why the size of the atom along the period will be decreasing. In a group, the atomic size of the elements increases from top to bottom because valence shell increases, right? The number of shell increases, and the distance between, as the number of shell increases, the distance between the nucleus and the shells increases. So this reduces the force of proton on it, right? There will be decrease in a force of a proton, pull force of a proton. That is why atomic size increases down the group. Right. Next. Metallic property, or we can say electropositive nature. So when you see the third period, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, metal have a tendency to lose electron and become positive ion. So that is called electropositive nature. So in the period, the metallic property decreases along the period, that is from left to right. In the group, the metallic property increases down the bottom, right? Next, non-metallic property. So it is vice ulta from metallic property. So non-metallic property, that is the what we can what we can say, the probability of gaining the electron increases along the period, decreases down the group. Okay. So this is regarding the properties of a periodic classification of elements. What all properties we learn, guys? Valence electrons, valency, atomic size, and also metallic property, non-metallic property. So this is the last concept of the periodic classification of elements. Here we ended up with the periodic classification of elements. So in the next session, we will start with a new chapter. Until that, take care. Have a nice day. Bye-bye.